Good afternoon, everyone. As I'm taping this lecture, it is Friday afternoon, and the date is May 1st. We finally made it to May, and the weather outside is absolutely fantastic. It's supposed to be well in the 80s today with sunshine. But for the time being, I'm going to spend probably the next 45 minutes or so reviewing with you for the final exam, which is going to be on Wednesday next week, Wednesday, May 6th. And I'm thinking that I'm going to have the exam available to you on Canvas for the whole day, that day, Wednesday, probably from 8 in the morning until midnight, so that you have at least plenty of time, any time that day that works with your schedule to take this exam. The final exam, just for your information, if it hasn't been made clear before, it is not going to be cumulative this semester due to the COVID-19 virus. I was originally planning to have it be cumulative, but because of the virus, things changed dramatically. And so now the final exam is really going to be like a Unit 2 test for the course, which means the final exam is going to cover 20th century scales, 20th century rhythm, 20th century chords, harmonies, that kind of thing, and then it'll also cover the atonal music that we've been discussing for the past several weeks. So that's just to give you a heads up as to what you can expect to be on the final exam and when you can expect the final exam. Before I forget and before I get started with the review, I do want to urge you and encourage you to fill out your course evaluations online. I believe you can access them through Canvas, but if you can't, I'm sure you know another way, or you have other ways to access your course evaluations. The last day to submit course evaluations would be Monday, May 4th. And I do want to especially encourage you to do that this semester, considering the circumstances and the situation that we've all had to deal with, certainly the second half of this semester, that is following spring break. And take that into account, obviously, when you fill out your course evaluations. I was just thinking that this is going to be my last video for the Theory 4 course, and again, good luck to all of you. This should be then the last, I guess, lecture that you hear from me in terms of any theory at Wayne State College. But let's start on the first page of the final exam review, which is what I have here on the screen. At first, you are asked to write out some scales, but instead of using accidentals for these 20th century scales, you're asked to supply a proper key signature for these modal scales. So in order to, at least one way that I do this, that I know how to, and that I've explained how to notate a modal scale using the key signature, is I know that Dorian, you will get the right half-step, whole-step pattern for a Dorian scale if you start on the second degree of any major scale, starting on the second step of any major scale. The Phrygian, you would get the right scale starting on the third scale degree of any major scale. Lydian would be starting on the 4th degree, Mixolydian would be the 5th degree, Aeolian would be the 6th degree, and Locrian would be starting on the 7th degree of any major scale. So what I have done is I have asked myself, okay, I know Dorian refers to starting on the 2nd degree of a major scale, and I asked myself, okay, let's pretend what major scale is E flat the 2nd scale degree of? What major scale is E flat scale degree 2? And the answer I come up with is the D flat major scale. So what I do is I write the key signature for D flat major over here, but you got to be careful, write the scale or the notes from E flat to E flat. The scale from E flat to E flat with D flat major's key signature will give you the right accidentals to spell an E flat Dorian scale. I believe there was one other way we talked about doing this in class while you guys were still here. What you can do is you can remember that Dorian is like the natural minor scale, but with a raised 6th scale degree. So what you could do is put on all the accidentals that you need to, and then raise the 6th scale degree, make that one adjustment, and then whatever accidentals you have left, however many flats that is, you could then erase them from each of the notes in the scale and just collect them and shove them all back into the key signature. That is another way that you should get the same answer. Going to the G Lydian scale, I know that Lydian refers to starting on the 4th scale degree, or it's like starting on the 4th degree of a major scale. So I ask myself, or pretend then that G is the 4th scale degree of what major scale? And you should come up with the answer of D major. G is the 4th scale degree of D major. So I have used the key signature for D major, but if I write the notes from G to G, using D major's key signature, I will have all the right pitches for a Lydian modal scale. Over on the right side, Phrygian. Phrygian refers to the 3rd degree of a major scale. So let's imagine or pretend that F is the 3rd degree of a major scale. What major scale are you thinking of? Well, I hope you're thinking of D flat major once again. So what I have done is I have employed the D flat major key signature, but then I've written my notes from F to F. And finally, for C Mixolydian, Mixolydian refers to scale degree 5 of a major scale. C is scale degree 5 of what major scale? What major scale? The answer is F major. So I'll use F major's key signature, which is 1 flat, and I write the notes from C to C, and that 1 flat, B flat would apply to this one, and so you can see how C Mixolydian would be just like a major scale, but with a lowered 7th scale degree. Works both ways. Moving right along to section 2 of this review, it's asking for which of the 20th century rhythmic processes that we studied, again, right before we left for spring break, which of those following rhythmic processes is being used here in this example. And let's see if I give you any choices to choose from. Yes, I do. I give you a lot of choices to choose from. And we'll go over all of these choices on another page of the review, but for right now you need to know that this is an example of asymmetric meter. Asymmetric meter, once again, is a meter signature that has an odd number on the top, except for the number 3 or the number 9 on the top of the meter signature. Okay? Any other odd number besides 3 or 9 on the top of the meter signature refers to an asymmetric meter. So 5/8 would be a good example, 7/8, 11/8, 13 is the top number, etc., etc. All these would be examples of asymmetric meter, and that's why I have my answer as it is here for this example. Section 3 on this page refers to planing. It asks us to complete the following passages using chromatic planing for the first example and then diatonic planing for the second example. Now I will show you the answers in a moment. Just a quick reminder, chromatic planing means that every single note has to move in the same direction by the exact same interval. Whether it's a major second or a minor second or a major third or a minor third. And when you do that, when you keep the intervals very strict and you move them in the same direction by the same distance, what you'll do is you will end up preserving or keeping the type or quality of chord that you start with. So for instance, in this first example, I have B flat, D, and F sharp. That is an augmented triad in first inversion. Well, using accidentals as necessary, using them freely so that I can move all the notes by the same direction, by the same exact interval, is going to help me preserve augmented triads in first inversion all the way to the end. So for instance, if this note C in this top voice moves up to D, that's a major second, then this G sharp going up a major second would have to go to A sharp, and this E going up a major second would have to go to F sharp. C, E, G sharp is another augmented triad in first inversion, and D, and if we had F sharp here and A sharp here, that would be another augmented triad in first inversion. And we preserve that same chord quality or type all the way to the end, using accidentals as freely as you need to make the triads what they need to be. The diatonic planing, really quickly, here is where the intervals that you move by in each voice, they have to move in the same direction, but they don't have to move by the same exact interval. They only have to move in the same direction by the same generic interval. So for instance, if one voice moves up from B to C, for instance, which is a half step, the other notes in the chord, they don't have to move up a half step. They can move up a whole step, as long as they move a second. When you do this, you do not add any accidentals to the passage in diatonic planing. No accidentals are needed. All of the chords end up being the type or quality that they would be according to the key signature. Let the key signature, or in this case the lack thereof of a key signature, determine what the chords are. So in this case we have D, F, A, C, which is a minor minor seventh chord, but the next seventh chord might not be exactly minor minor seventh. It could be a minor major seventh or another type of seventh chord. But that's okay, because this is diatonic planing. We're not concerned about preserving the same type of chord throughout. We're just going to let the key signature take care of whatever chords they turn out to be, and no accidentals will need to be used in diatonic planing. So here is the answer to the chromatic planing on your review sheet. This comes out of the workbook on page 284. This is number 2, and hopefully you can see from your vantage point all of my accidentals and the final answer there for the chromatic planing of augmented triads in first inversion. And by the way, I would encourage you, if there's anything in this review that you feel I either go over too quickly, please go back in the video, pause it, stop it, rewind, replay any part that you need until the concept is a little more cemented and firm in your mind. Because I really do want you to finish this semester strong, especially after you've worked so hard for so many semesters in theory. I want you to finish as strong as you can. And with this review lecture and with the review that you have at home that you're working on, studying all that will give you the best chance for success. The diatonic planing example is just like number 3 on page 285 of the workbook. So if I were to freeze this here, you should be able to see that we start with D, C, F, and A. and then we go through with generic intervals moving the same direction with no accidentals, and this produces diatonic planing, and I'll give you a moment to look at that to make sure that your answer is the same as mine. So moving right along to the next page of the review. We're back to a few scales again, 20th century scales. The first one, as you can see, asks you to spell a Phrygian scale starting on C. And for this, with no key signatures, but this time we actually use or apply accidentals to every note that we need to make the scale correct. This is where I would use my knowledge of how Phrygian very closely resembles the natural minor scale, but with one adjustment. The Phrygian scale, or mode I should say, is just like the natural minor scale with a lowered second scale degree. So a natural minor scale on C would be 3 flats. It would be B flat, E flat, and A flat. But then I also lower the second scale degree a half step, so that makes that D flat. And I have my final answer from C to C. With those flats, make it Phrygian. The whole tone scale, once again, please remember that the whole tone scale is exactly what its name implies. It is a series of pitches, ascending pitches, that are each a whole step apart from the beginning to the end of the scale. So we want to spell a whole tone scale on D here. So I'm going D, and then up a whole step is E. Up a whole step is F sharp. Up a whole step would be G sharp, but you may spell any pitch in this scale enharmonically if you'd like. It does not matter. So I used A flat, and then a whole step up from A flat is B flat, and then a whole step up from there is C, and this is what's called the octave-related pitch. It is the same pitch as the first note of the scale, just an octave higher. As a quick reminder also, the whole tone scale has 6 different pitches. 6 different pitches. Here I have D, E, F sharp, A flat, B flat, and C. And they're all a whole step apart from each other. The major pentatonic scale. Pentatonic means that it is a 5-note scale, so there are 5 different pitches. Again, I do not count the octave-related pitch. Now, for the exam, you need to have this memorized. A major pentatonic uses scale degrees 1, 2, 3, 5, and 6 of a major scale. That I'm asking you, I'm telling you, it would be in your best interest to have that information memorized. Okay. Starting on an E, let's find what scale degrees 1, 2, 3, 5, and 6 are in E major. Well, after E, scale degree 2 should be F sharp. Scale degree 3 is G sharp. Scale degree 5 is B, and scale degree 6 is C sharp. And then the octave-related pitch once again. So 1, 2, 3, 5, 6 of a major scale will get you the major pentatonic scale. Going to the next side, spelling an octatonic scale starting on C sharp, and we're told that we're going to alternate half and whole steps, but start with the half step. Once again, the octatonic scale is an 8-note scale. It has 8 different pitches, and the way you spell the scale is you alternate ascending half steps and whole steps all the way to the end of the scale. Here it is specifically told us that we are start with a half step above the first pitch, and then a whole step, and so on and so forth until we get to the end. Feel free to spell any, if you have any of the pitches I have on the board here spelled enharmonically, that is perfectly fine. When you spell octatonic scales especially, and whole tone scales, enharmonics do not matter as long as you have the right pitch class. So for this octatonic scale, I have C sharp up a half step is D, then the whole step from there is E, a half step is F, then a whole step up from there is G, a half step from G up is A flat, then a whole step up is B flat, then a half step up is B natural, and then one more whole step will get us to the octave related pitch, the same pitch where we started, just an octave higher. And not counting the octave related pitch, we should have 1, 2, 3, 4, 5, 6, 7, 8 different pitches. The Dorian scale below, I'm using my knowledge of the Dorian scale being just like a natural minor scale, but with one adjustment, and that adjustment is to raise the 6th scale degree. So, because my tonic note in this modal scale is E flat, I'm going to fill out all the accidentals I need to make it E flat natural minor. I'm going to do that first, and then make the modal adjustment. The key signature for E flat minor is 6 flats. So, originally I would have a flat on every single note except for the F, and that would make it E flat natural minor. But to make it Dorian, my final answer, I need to raise the 6th scale degree. So instead of C flat, I should have C, plain C, or if you want to write the natural in there, that's perfectly fine. C natural is the correct 6th scale degree to make this E flat, what was natural minor scale, to make it Dorian. And finally, the minor pentatonic scale. Again, be best to have these 5 scale degrees memorized. The minor pentatonic scale is simply taking scale degrees 1, 3, 4, 5, and 7 from the natural form of the minor scale. Not the harmonic form and not the ascending melodic form. From the natural form. So, starting on F, let's think of the F natural minor scale. We know F is scale degree 1. Scale degree 3 is A flat. Scale degree 4 is B flat. Scale degree 5 is C. And scale degree 7, remember, of the natural minor scale, that's Te, or the lowered 7th scale degree, and that's going to be E flat in an F natural minor scale. Moving on to some chords, 20th century harmonic structures. I have the first 5 on your review sheet shown here on the screen. There are many choices in the instructions, and it's very important, especially on the final exam too, to read the instructions closely and carefully, because especially if there are options or multiple choice answers, you want to make sure you've looked at all the options and don't include an answer if it's not one of the options in the instructions. In these instructions here, we get to choose between quartal and quintal chords, sequential chords, split third chords, lead sheet symbols for tertian chords, and then also polychords. So the chord structure in number 1 is a sequential chord. B and C and C sharp and D. Those can all be formed and arranged in seconds. That's why we call it a sequential chord. And remember, a sequential chord in its closest possible mashed up, squished position is known as a tone cluster. And I think that was another, section that or choice that I added to this section of chords. So number 1 is sequential. Number 2, this one is actually built and constructed out of stacked perfect fifths. So we would call this a quintal chord, or Q5. Number 3 is a chord built out of stacked perfect fourths. So it is a quartal chord, or Q4. Number 4, to me, looks like these notes don't really go together and can't be combined into a single chord. we have an F sharp major triad in the left hand, and we have a G major triad in the treble clef. And those notes don't really mix and go together very well, so I'm going to say that this is an example of a polychord. It has two distinct chords, a G major chord over an F sharp major chord. And I'll just use the pop symbol for each of these two distinct triads for my answer. So the pop symbol for G major is capital G, and then I'll draw a line, or you can use the line that's provided there. And for the bottom chord, I'll just use the symbol F sharp, capital F sharp, for an F sharp major triad. Again, that's a polychord. Finally, on this screen here, number 5, these notes can be combined to form one kind of little larger than normal type of chord. This has 5 pitches to it. We have a root, a third, a fifth, a seventh, and a ninth. Notice that the ninth is in the highest voice, which is where it should be. And this turns out to be a ninth chord on F. And so the analysis symbol for that is just, the pop symbol for that is just capital F and then the number 9. An F9 chord. Okay, the final 4 that I have left on this page, number 6, you can see that I've called that an ST, or a split third chord. That's because it's an F, A, C chord, but we have both the minor third, A flat, and the major third, A natural, in the same chord. We can't say whether or not for sure this chord is a major triad or a minor triad. It's one of these 20th century chord constructions. So the only thing we have left to call it, because it has both the major and the minor third in the chord, is to say that it is a split third chord. A split third chord. Number 7 is just your standard, looks like major minor 7th chord in first inversion. E flat is the root, G is the third, B flat is the fifth, and D flat is the 7th. It's a dominant 7th chord in first inversion. So the pop symbol for a dominant 7th chord is the root with a 7. And then we know slash notation with pop symbols, the letter of the pitch after the slash, in this case, means the lowest sounding note of all of them in the chord. Okay? So it's an E flat major minor 7 or an E flat dominant 7th chord with G in the bass. On number 8, these tones can actually be put together to form one large chord. Here it looks like we have a root, a third, a fifth, a 7th, a 9th, and an 11th. And notice the 11th is in the highest voice. This is a chord that can be stacked in thirds. So it is one of our more traditional tertian chords, even though it's what we call an extended or larger tertian chord than the normal triads and sevenths. So the pop symbol for an 11th chord in this case is just the root, which in this case is C, followed by an 11. It is a C11 chord. Now I don't know how well this added measure is visible on your review, but I have in the left hand G, A flat, and B, and in the right hand I have C, D flat, it looks like, and E. And you can see that all of those notes are right next to each other. They're adjacent. They could not be forced any closer together, and they're all built out of, or constructed out of seconds. That's what the chord is. But they're in the closest possible position. So I call this chord structure a tone cluster. A tone cluster. Once again, I don't know how well you can see this, but pay attention to the options or the choices you have for answers up in the instructions. Of all the rhythmic procedures we learned, these are the choices you have. Added value, displaced accent, metric modulation, mixed meter, or non-retrogradable rhythm. Okay? So those are 5 choices. We have 5 exercises. Probably likely that each of these answers in the instructions will be used once and only once. Let's just do them one by one in order here. The first one has to be a non-retrogradable rhythm because the rhythm sounds the same whether it's read forward or whether it's read backwards. Remember, non-retrogradable in this case means that when you play or sound or even write the backwards version, the retrograde, you do not get anything new or different or distinct. In fact, you get the exact same thing. So we're saying that because we don't get anything different when we play this or write this backwards, we get the same thing, we're saying that it's non-retrogradable. And remember, a non-retrogradable rhythm, if you think of it as being kind of like a rhythm or a rhythmic palindrome, something that reads and sounds the same forwards and backwards, that's your key to recognizing and spotting non-retrogradable rhythms on the exam. Number 2, this has to be added value, because if I compare the second measure with the first measure, there's an 8th note added. And if I compare the third measure with the second measure, there's a dot added. And if I compare the next measure with the third measure, I've got a 16th note and a tie added, etc., etc. So this number 2 must be the answer, added value. Number 3 has to be mixed meter. A quick way to spot or recognize mixed meter is to see lots of meter changes. Whenever the time signature changes very frequently, in this case it changes every measure, that means mixed meter. Frequent, persistent time signature changes or meter changes means mixed meter. Number 4, metric modulation. I hope you got that one pretty quickly. Again, whenever you see a musical or a rhythmic equation written above a couple of the measures of a musical passage, like such a rhythmic value equals such a rhythmic value in the next measure or in the new meter, that's a tip-off that it should be metric modulation. Anytime you see a rhythmic equation, remember metric modulation. And the last one at the bottom, because we've gone through all the rest of them, it's the only one left. Number 5 has to be displaced accent. But again, that can be confirmed by when you see that these accents are placed on weak beats or weak parts of the beat. That's a very clear clue and indication that you're dealing with displaced accent. Accents that are marked specifically to be on weak beats or normally unstressed parts of the beats. All right, the next page of the review may go fairly quickly. We'll see. There's not much to section A on this page. We need to reduce the following integers to an integer mod 12. Again, in the mod 12 world or universe, we need all of our integer answers to be between 0 and 11, including 0 and 11. They can't be any larger than 11, nor can they be any smaller than 0. So what happens when you have a number that's larger than 11? Well, just subtract 12 from it as many times as you need to until you get an integer within the desired range. So 14 minus 12, 14 is too big. Minus 12, you get 2, that's within the range. 17 is too big, subtract 12, you get 5. 21 is too large, subtract 12, you get 9, that's in the welcome range. 12 is actually a little too large, subtract 12, you get 0, that's within the range. 8 is right in the range, you don't need to do anything to it. Negative 2 is too small, so you need to add 12 to it to get it into the 0 to 11 span. So adding 12 to negative 2 gives you positive 10. Adding 12 to negative 3 gives you 9. And adding 12 to negative 9 gives you positive 3. The brief section on transposition has 4 pitch class sets to transpose. Remember, with transposition, all you do is you take the subscript, the subscript, which is in generic terms is referred to as n. You just take that number and you add it to every member of the set in turn. And then whatever that, and by the way, you're in the mod 12 arithmetic system here. And whatever answers you get, that'll be the transposition. So for example, in number 1, when I add 3 to 6, 5, and 2, I should get 9, 8, and 5. And that's how you transpose the pitch class set 6, 5, 2 up 3 semitones. That's what that means. That's what you're doing. Number 2, transposing this pitch class set up 1 half step or semitone. We're going to end up getting 10 and 0 and 5. Remember, in the mod 12 system, 11 plus 1 is not 12. 12 is just a bit too big. Subtract 12 to get it within the right range, and you get 0. 10, 0, and 5. Number 3, adding 11 to each of these pitch class integers. The final answer you should get is 11, 2, and 1. And for number 4, adding 6 to all 3 of these members gives me the answer 0, 2, and 4. 0, 2, and 4. And we're not dealing with any normal orders yet or any prime forms. So, just using the curly parentheses with commas is standard for the unordered type of set that we're given there. Alright, in the inversion section, inversion is a 2-step process technically. What you need to do is invert all of these given sets by subtracting all of their members from 12 first. And then with those numbers, then transpose the set up this number of semitones that's shown by the subscript. So inversion is defined in set theory or atonal theory as subtraction from 12. In the mod 12 system, 12 minus 3, 2, and 1 respectively should give us 9, 10, and 11. I still have the transposition operation to complete. In other words, I need to add 5 semitones to all 3 of these integers now. So my final answer is going to be the pitch class set 2, 3, 4. Applying the same process to numbers 2, 3, and 4, you can see after inverting the set of number 2, I get 4, 5, and 7. Adding 9 to each of those pitch class integers gives me the final answer of 1, 2, 4. Number 3, subtracting each of these 3 integers from 12 in a mod 12 system gives me 9, 5, and 6. And then adding 10 to all of them gives me the final answer of 7, 3, 4. And then the last one, subtracting all these members from 12 in that pitch class set, I should get 8, 7, and 0. And adding 7 half steps to all of those pitch classes gives me the final answer of the set 3, 2, 7. 3, 2, 7. The last section on this page of the review asks you to determine several things. First of all, the normal order of a set, then the prime form, and then the interval vector. Okay. Now, even though it's not my preference, we are given these 4 unordered sets to start with. We're given them using letter notation, pitch letter names. I tend to prefer to work with pitch class integers, especially to do my calculations. But I can see the benefit of actually envisioning these numbers, these pitch class integers, as pitch classes on a staff. So the first one, you're given the unordered set D, C sharp, F sharp. And when you find the normal order of that set, you'll end up coming up with C sharp, D, and F sharp. In other words, C sharp first, then D, and then F sharp. That's the normal order. And normal orders, remember, are always placed in square brackets with commas. Another way to think of this, instead of C sharp, D, and F sharp, if you have the pitch class integer answer 126, you're doing just great. 126. When you go through the steps of finding the prime form, you should get the prime form 015. Once again, prime forms, they use curvy parentheses, but no commas. This is the name of an entire set class. That's what a prime form is. And you can look in the back of your textbook in Appendix C to find this prime form. If it's not found in Appendix C, then you've made an error in your calculations and you need to go back and redo something until you get a prime form that is found in your appendix. I have already looked and I have located the set class 015 in Appendix C of the book, so I'm pretty sure that I'm right on the money here with this one. The interval vector for this is 100110. Again, this just tells us it's a 6-digit number that tells us the number of instances of each interval class. This interval vector tells us there's one instance of interval class 1 in this set, no instances of interval classes 2 or 3, one instance of interval class 4, one of interval class 5, and no instances of interval class 6. And once again, the interval vectors, especially if you have the prime form, you can also look in the appendix and verify that your interval vector is correct, because the interval vectors for all the prime forms for all the sets are also found in the appendix in the back of your book. Alright, so that goes through the process. Let me just cover some of these answers here. For number 2, your normal order should be C, E flat, F, or 0, 3, 5. The prime form, when you go through all those calculations, you check the transpositions and you check all the inversions, you reduce them down to sets that start with 0. You should come up with the prime form 0, 2, 5, and its interval vector is 0, 1, 1, 0, 1, 0. Remember, pitch class sets with 3 members will have 3 total interval classes represented in their interval vectors. You see how 1 plus 1 plus 1 is 3? And again, 1 plus 1 plus 1 is 3. There's 3 intervals. We didn't miss any. Pitch class sets that contain 4 pitch classes will have a grand total of 6 intervals in the interval vector. And I can double check that by adding the number of instances really quickly. In number 3, I have 2 plus 2 plus 2 is 6. And in the last one, I have 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. At any rate, number 3 I thought was maybe the hardest one to find the normal order for. There are a couple different arrangements that have the same distance or smallest span between the outside notes. And I had written down both of those that had ties for the distance between the outside notes of the pitch class set. Well, when I checked the when I checked the distance from the first note to the next to last note, I also had a tie between these two arrangements again. And then when I checked the distance from the first pitch to the next most outside interval, so to speak, I had a tie again. So both of these sets are exactly compacted the exact same way. They have the same distance between their outside notes, and they're both equally compacted to the left of the set as well. There's no difference. So which arrangement then is going to be normal order? Well, when you have ties all the way until you have no more intervals or distances to check when there's an unending tie, pick the arrangement that starts with the smallest pitch class number. And out of this one starts on F sharp, and that is pitch class 6. Compared to this arrangement, which starts on pitch class C or 0, I'm going to choose this arrangement as the normal order. So my normal order for number 3 is C, C sharp, F sharp, G, or in terms of integers, 0, 1, 6, 7. It turns out that the normal order 0, 1, 6, 7 is also the prime form for this set. And the interval vector is 2 instances of interval class 1, none of interval classes 2, 3, and 4, and then 2 instances each of interval classes 5 and 6. And finally, number 4, the normal order you should have is B, C, E flat, F, or translated into integers 11, 0, 3, 5. The prime form of this pitch class set is 0, 1, 4, 6, so that is the name and the label that represents the entire set class. And the interval vector is 1 instance each of all the interval classes 1 through 6. So the last thing we need to cover are these questions about analyzing a short passage of atonal music, coming up with normal forms and set classes, prime forms, and other questions about the piece. So what I'm going to do is I'm going to place a copy of the score on the screen here, and it should contain a lot of groups of pitches that have been circled or segmented into pitch class sets for you. And that was designed in order to steer you in the right direction for calculating the answers to these questions, so that you didn't have to start from a blank slate on the score and just pick any random pitches you thought might work out to be an important pitch class set. So let me, like I said, put this up on the screen, and we'll see if I can get most of it to show. And then I'll go through the questions on the page right before that refer to this atonal passage. All right. So the first question says, determine the normal form of the initial 4-note melodic gesture. To what set class does this PC set belong? So they're talking about the 4 notes in measure 1. The opening 4 notes. And the pitches there are in a random order: C, C sharp, F sharp, and G. Well, we need to find the normal form and the prime form to find out what set class this belongs to. And going through all the calculations, you should find that the normal order of this pitch class set is 0, 1, 6, 7. That is also the prime form, the set class to which this set belongs, 0, 1, 6, 7. And if you're keeping track of fort names for set classes, it turns out to be set class 4-9 in your book's appendix. So let me see if I can... Here's the answer again right here for that one. Number 2 in this review says, find 2 other melodic instances of this set class, 0, 1, 6, 7. And then circle these occurrences on the score and mark them with the appropriate fort name. Well, you don't have to mark them with the appropriate fort name. I just mark them with the prime form. That's how I label set classes. So let's see if we can find any other instances of the set class 0, 1, 6, 7. Well, Again, if you can see that from where you are, here's an instance of 0167. It has the same exact pitch classes as this measure. I see another instance of 0167 down here in measure 7. This kind of vertical circle, those pitches that I've grouped together there. I see another instance of set class 0167 with these 4 pitches in measures 4 and 5. I think that's sufficient to satisfy the question number 2. All right, number 3 says that the 3-note melodic cell G, F sharp, and B flat plays an important role in the passage. This happens to turn out clearly in the last measure. Be aware that the clef has changed in the top staff of the last measure to bass clef, so these notes are indeed B flat, F sharp, and G. Determine the set's normal form and to what set does it belong, to what set class does it